Cool. So we're talking about number 4 from the week 6 homework 2. So, where did you start? Where have you started with this, Destiny?
Okay, I factored out the 5 over n cubed plus 5 n squared. I factored out n squared from that,
Cool.
from the
Sounds good.
denominator.
Yeah, so that's good. So whenever you start off one of these rational equations, it's nice to factor the denominators first. And then what did you do?
That's where I
Okay,
got
so that's where
lost.
we are. Cool. So, one of the things with all these rational equations, it's really annoying having fractions, right?
Yeah.
So, yeah, exactly. So, something that's useful is that we can do one of two things. Essentially, what we're going to do is we see that if I multiply everything by n squared, if I multiply the left and the right hand side by n squared, that will allow me to get rid of, it'll multiply everything, right? And that'll allow me to get rid of this one and this one, right?
Yes.
That'll let me get rid of those denominators if I multiply by n squared. And on this guy, we will end up with a n squared on top, right?
Yes.
So essentially, actually, you know what might be a better way to put this? If I multiply everything by n squared, I end up with n squared, n squared, n squared, right?
Okay. Let
And
me
then this is where
write
we can
that.
see that the n squared would cancel on this fraction, and it would cancel on this fraction, right?
So I'm multiplying n squared to everything.
Yeah, so what we're going to do is we're going to basically just take the factors of our denominators and multiply it to all the terms. And so in the end, after this one, we'll have 5 over n plus 5 equals 4n squared over n plus 5 plus 1, right? And now what do you think we can do? So notice how we've made our denominators simpler. We no longer have n squared in the bottom.
Wait a second. Oh, the n squared only multiplies to the top, not the bottom.
Yeah, so
Oh.
when you multiply a fraction, if I like a over b, this is actually like tons of people get this confused. Like if I had 2 times a over b, that only multiplies to the top. If I took 1/2 times a over b, then it would go to the bottom, right? Because the idea is that the top is where things are multiplying, and the bottom is where things are dividing. That's a little side note.
Okay.
So then for now that we've gotten rid of n squared, how do you think we can get rid of n plus 5 here?
Um, multiplying n plus 5
Yeah,
also.
exactly. So if I multiply everything by n plus 5, there's no real reason why I'm drawing it on the right hand side. I'm just doing it because, I don't know, space, because there's no space here. So if I multiply everything by n plus 5, then we will end up with 5 times n plus 5 over n plus 5, right? Equals 4n squared times n plus 5 over n plus 5, and then plus 1 times n plus 5, which is just, we could just call that n plus 5, right?
Okay.
And so now can we try to simplify this equation a little bit more?
Yes.
Yeah. So what can we do then?
Wait. Writing. What happened to the 1?
Oh, it was 1 times n plus 5, right? So that's a good point. What did happen to the 1? I skipped a step.
Oh,
I skipped a step. That's my. So now what can we do with this?
you can. Oh, cancel all the n plus 5s out.
Yeah. So this n plus 5 cancels. This one cancels, and we will end up with 5 equals 4n squared. plus
Cancel from 4.
plus n plus 5. And now we just need to solve this equation. At this point, solving this equation is just like when we used to solve polynomials. So this is why, this is why we were talking so much about factoring things. So we want to try to get everything to one side so that it's equal to 0. So I'm going to subtract 5 from both sides.
Okay.
And I would get that 4n squared plus n. And on the left-hand side, I have 0. I'm going to write it on the right just because, we don't need to do that. Let's not confuse ourselves. So 0 equals 4n squared plus n.
And then I just factor from there.
Exactly.
Oh my gosh. Well, as soon as I get to this, you make it seem so easy.
Well,
So my A is 4.
yeah. To be honest, like, that's how math sometimes is. Like, I swear, dude, like, until you try to do it yourself, it can seem so easy when you watch someone else do it, right?
If I don't have, it's 0, right? When I don't have a.
Oh, did you factor it?
Oh, nope, forgot. Factor out an n.
N equals 0 will be one of our solutions, but we could factor out the n, and we're left with 4n plus 1, right? So from this guy, we get 0. But what about from this one? When would 4n plus 1 equal 0?
Negative 1/4.
Yeah, negative 1/4. So our solutions are 0 and negative 1/4. Something that I like that we should do when we're solving rational equations, you know, because there was this division by 0. Sorry, not division by 0. Because there were these denominators, we should check with our solution that none of them give us division by 0, right? So when we look at the original equation, remember how there was a when I plug 0 in for n squared, that would give us 0 in the denominator, right?
Yes.
So essentially what we're seeing is if I take my original equation and I plug 0 in, so 0 cubed plus 5 times 0 squared equals 4 over 0 plus 5 plus 1 over 0 squared. What we see is that I end up getting division by 0 when I plug in n equals 0. Which is not okay, right? Because division by 0 gives me an undefined answer. It's just undefined. So what that means is that this actually should be crossed off from my solutions list. So really, the only solution is n equals negative 1/4. This is why we kind of concern ourselves with the domain of functions, because there are times where you can get a solution that doesn't actually exist. And that's something that we would call like just like an invalid solution or an undefined solution. Cool. So we end up getting n equals negative 1/4. Does that sound good?
Yes.
Awesome. Then I think I'm going to end this little video.